Aloha! Welcome to another episode of The Curvature Amateur. I'm your host, Louis Montagne. And today, once again, I'm going to show you some footage that I took with my Nikon P900 from the Kohala Mountain Road looking at the other islands of Hawaii. So, just to show you where I was, let's see. This one here. If we live on a globe, do we live on a globe? Well, this video should be able to knock out that hypothesis way out into over the ballpark. I should make a home run with this one. So, if we live on a globe, how come we can't really fit all of America, North America and South America on this globe? But anyway, let's see where I was observing from the big island of Hawaii, from the Kohala Mountain Road. Here are the Kohala Mountains. And where I was standing was standing right by that pu'u here. A pu'u is a little crater. And let me try to recognize some features here. So up around here, there's a sign on the side of the highway. It says 2,500 feet of elevation. And I was actually closer to this pu'u here, not this one. So I was about here. And over here, there's a sign on the side of the highway that says 2,000 feet elevation. So I was above 2,000 feet, but below 2,500 feet. Okay, I was about here. All right, so let's put this in 3D. And let's look towards the other islands. Here is Maui, big one. And over here is Ka'olave. Here is Lanai. And further out there is Oahu. But let's take a closer look at what we can see with this Google map. Okay, so my alignment is about like this. So we see Ka'olave, Lanai, and Oahu, and we already kind of see the two little peaks over here, which on my camera look a bit like two nipples sticking up. So let's go take a closer look at Lanai, because Lanai is just before what we can see of Oahu. It's as low as I can get it. So we can see the shape of Lanai here, the summit, and over here is a kind of a plateau, and down below here is more plateau. And I don't see any 2 points, 1 point, 2 point. I don't see any of that on this island. Okay, you can see that it just drops and drops and drops. But over here on Oahu, we see those 2 points here, which, like I just said, they look a bit like nipples to me, sticking up. And as we go towards Oahu, you can see that those two little peaks are these two guys here. This one here and this one here, which I believe is it Diamond Head? No, Diamond Head is lower than that. Oh, this is Diamond Head here. You see this taller peak here and this one here. As we back up, it looks like two peaks. 1, 2. And we can't see this higher peak here because it's kind of hidden by the island of Lanai, as we will see on my Nikon P900 shot. Alright, so let's go back to 2D. Sorry, we're in the water here. And we're going to take a measurement of the distance from Oahu to my observing point. Turn it a little bit so we can fit more into the screen. Alright, I was about here. I measure the distance to Oahu. So, like we could see earlier, this peak here was visible, and this peak was visible. But since we can see the furthest one, let's just grab a glimpse, a little sight of this distance. 169 miles. Okay, 169 miles away. I can see that. Alright? So, let's see how tall is Oahu here on this website. Yes, Google how tall is Oahu. 4,000 feet and 3 more feet away. 4,000. Alright? And remember, I'm standing below 2,500 feet. I'm standing just over 2,000 but below 2,500. And let's go to this website here, how to calculate earth curvature. My favorite website, how to calculate earth curvature, is this one. Even though there's many more earth calculating websites on Google that will all give you the same number and the same way of calculating. So if you find any other math, let me know about it, and please make those maths and see who's wrong here. So on this website, Robert, the expert here, is being asked by other people at all levels, how can I find the curvature per mile of Earth's surface? What is it? So Robert started with the radius of the Earth, which he claims to be 3,963 miles. All right? You see, he puts an accurate number. He puts a solid number. There's no point something. Anyway, he didn't round it off at 4,000 miles. He didn't round it off at 3,900 miles or not even 950 miles. So he has an accurate number. And why did he use this number? Did anybody go out there? Because we know nobody went to the moon. So anybody go out in space and pulled out a big measuring tape and put the end of the tape very accurately at one end of the Earth and the other end of the measuring tape at the other end of the Earth and say, this is how wide our Earth is? I don't think so. And he used the Pythagoras triangle, a squared plus b squared equals c squared. And he only used 1 mile to make his math here. But we are measuring 169 miles. Okay? And his answer is he got 7.98 inches in 1 mile, which is approximately 8 inches in 1 mile. Okay, let's pull out our calculator. Okay, let's see first what is the value of 2/3. 2 divided by 3. Not to put any bad numbers out in the air, but you see it's 0.6 periodical. All right? Now, 8 inches into a foot is the exact same value of 2/3. Okay? Now, I want to know how much is 7.98 inches into a foot. What is the proportion? It's 0.665, so it's a little bit less than 0.6 periodical. All right? Now, we have 169 miles. We have to square that number because we have to square the distance measured. So we multiply it by the same number. So we get this big number here, 28,561. So we got to multiply that by 0.665, and we get 18,903 feet. So we shouldn't be able to see anything below that. Okay? We shouldn't be able to see any. If my eyeball was at the ocean level on the island of Hawaii, I shouldn't be able to see anything below 18 or almost 19,000 feet. 18,993 feet. I shouldn't be able to see anything below that looking 169 miles away. Okay, does that make any sense to you? Now, let's take another look at this map here, just to confirm that on Lanai, which we're going to be looking over its shoulder to be observing Oahu, we can see that it's all sloping down. There's no two nipples sticking up anywhere. Like the summit here, it all slopes downward. Okay, this is like a big plateau, and there's no other peaks anywhere else in sight. Okay? Now, let's go take a look at my shot I got with my Nikon P900 from the Kohala Mountain Road. Alright, let's play. Thank you. So here's the island of Maui, the big one in sight. In front here on the foreground is Kaolave. Over here is Lanai. And we can already see something out there. Those two nipples sticking out. Let's take a closer look. You see, do you think they're part of the island of Lanai? You see those two peaks? Choop, choop. Choop, choop. Let's take a little closer look. Is that part of Lanai? It looks a little darker than the ground of Lanai. What do you think? What do you think? This one here should be 169 miles away from what I'm seeing. And remember, the height of Oahu is 4,000 feet, and I'm standing below 2,500 feet. So if you add on the two, we get 6,500 feet if you want. And I'm not supposed to be able to see anything below. Below what, calculator? Below 18,993 feet. Does that make any sense to you? There's a whole lot of numbers missing. There's like over 12,000 feet missing in the math that would put us on a globe. Do we live on a globe? Do we need to believe that we live on a globe? Because if you haven't watched my videos about the maps I got, I got several maps that show from ancient cartographer that there's more land out there than what we're told, past Antarctica. And here's the little island of Molokini. Here's the on the foreground is La Perouse Bay on Maui, and we can see Molokai behind, not so clearly, but you can see a tone back there is Molokai, and again, we wouldn't be able to see Molokai on the globe. Already got a couple of videos on that. You should check them out. Here's McKenna Hill. by Big Beach and Little Beach of Makena. And here is Maui. You can see the summit here, the observatories. And the sun is about to set. You can see the sunlight shining on one side of the observatory. It's only the observatory on Maui, because on the big island, on Mauna Kea, we have the biggest gathering of the observatory. To observe what? Why do they have so many? And they want to stick another one up there, the TMT, against the will of native Hawaiians, the locals, or even haoles like me. Nobody in the smart mind want to have another telescope up there, especially one that's going to tap into the waters of the mountain. To observe what? What do they want to observe more out into fake space, which we don't really have above us? We have some kind of a dome, and that's about it. And there are many YouTubers that show and prove that we have a dome up there by shooting private rockets up there that hit something. It's not going any further, and it spins on itself because it can't go any further. And why do they keep us out of Antarctica? Why isn't anybody supposed to go to Antarctica? Anyway, that's what I got for you. If you're still clinging on to the globe theory, please wake up. If you think there's something out there, some kind of a disease that's going to kill us all, please wake up. Okay? We really need to see what's going on out there and stand up in front of a bunch of liars. Thank you for watching. Until next time, aloha.